Now we're moving on to a new set of Cornell notes. The title of these notes, Write Equations of Parallel and Perpendicular Lines. Here are your notes. Here we have 3 sets of parallel lines. This is a set of parallel lines. This is a set, as well as these 2 lines. Parallel lines, they have the same slope. Another tip with parallel lines is if you do have parallel lines, the lines, no matter how far along they continue on, no matter how long those lines get, if they never ever intersect, then you're dealing with a set of parallel lines. Your first subtopic, write an equation of a parallel line. Example 1, you're going to write an equation of a parallel line that passes through point -3, -5, and is parallel to the line y equals 3x minus 1. Step 1, determine if the equation is in slope-intercept form. So recall, slope-intercept form is y equals mx plus b. Here's your equation, y equals 3x minus 1, and as you can see, it is in slope-intercept form. There may be times when you'll be presented with an equation that's not in slope-intercept form. It may be in standard form, quite possibly it may be in point-slope form. But if it's in any other form other than slope-intercept form, you need to write it so that it is. Step 2, identify the slope of the given equation. Hence the reason why you need to write the equation in slope-intercept form. Identify what the slope is. Step 3, find the y-intercept by using the provided slope in the given point. Well, once we put the equation in slope-intercept form, we were able to identify that the slope is 3, right here. Then you're going to take that given point, which was -3 and -5, and substitute it for x as well as for y. Once you do that, you're then able to go through and solve the equation. Step 4, write an equation in the slope-intercept form. So you're going to rewrite the original equation as long as it's in slope-intercept form. Then you are going to substitute. Then you're going to substitute the values that you just found. So we discovered, or we were able to identify that the slope of the given equation was 3. So we plugged that in. Then once we solve the equation, we identify the value of b, or the value of the y-intercept, as being 4. And we plug that into the equation. And this equation here, the y equals 3x plus 4, this is the equation for a line that is parallel to the very first equation that we looked at. Now it's your turn. You have -2 and 11, and it's parallel to the line. Okay, I'm going to re-say this again. Now it's your turn. You're given a line that has a point as -2 and 11, and that line is parallel to the line y equals -x plus 5. Did you get y equals -x plus 9? Now what you're going to do is complete the textbook assignment at home. You're going to work on page 322, do numbers 1 and then 3 through 11 even. When we meet in class on Monday, we'll go over the textbook assignment, and then we'll get right into the problem solving related to parallel and perpendicular lines. Here are your notes on perpendicular lines. This is your next subtitle. As you can see here, we have a x-intercept and a x our x-axis, our y-axis, and these two lines are intersecting. Likewise, we have two other lines that are also intersecting. But one thing that both of these lines have in common is that, or both sets of lines, what they have in common is that they form a right angle. When you have two lines that cross each other or that intersect, if they form a right angle, just as both of these sets of lines do, then you're dealing with perpendicular lines. In perpendicular lines, the slopes of the two lines are negative reciprocals. Again, the slopes of the two lines are negative reciprocals. So, for example, if we're dealing with this set of perpendicular lines, this first line here has a slope of negative 3/2. The other line, this one here, it has a slope of 2/3. That fraction, or the slope, it was flipped. We found the reciprocal of that, which is 2/3. But because it's a negative reciprocal, we then will place or put a negative in front of the 2/3. Or excuse me, it will be the opposite of negative 3/2, which is 2/3. So let me say that once again. This line here, it has a slope of negative 3/2. This line here, since we're dealing with a perpendicular line, you will flip the 3/2 and it becomes 2/3. And now the sign is the opposite of whatever 3/2 is, which makes that fraction or the slope of this line 2/3. Alright, your next subtopic, write an equation of a perpendicular line. So you're given an equation, you're given a line, and it has a point 4 and negative 5. And it's perpendicular to the line y equals 2x plus 3. Step 1, identify the slope of the provided equation. So here's our provided equation here. And since it's already in slope-intercept form, it's quite easy for us to identify the slope, which is 2. Step 2, determine the slope of the perpendicular line. Since the given equation's slope is 2, the slope of the other line is negative 1/2. Again, since the given line that we have is 2, the slope is 1. Or excuse me, the slope is 2 over 1. In order to get the new line that we have to find out, in order to get its slope, we simply flip 2 over 1, which becomes 1 over 2. Since 2 over 1 is positive, this 1 over 2 now becomes negative. Since the given equation's slope is 2, the slope of the other line is negative 1/2. Step 3, find the y-intercept using given points and the perpendicular line slope. Again, find the y-intercept using the given point and the perpendicular line slope. So again, here is our y-intercept form. And all we're doing now is substituting the values that we have. The point that we used, or that we were given, was 4 and negative 5. So we substituted x for 4 and substituted y for negative 5. And the new line, since it's perpendicular, we discovered that the slope of that perpendicular line is negative 1/2.